Hey everybody, and welcome back for the continuing saga of my mother's 2008 Honda Civic. In the last video, I really ended up going down the rabbit hole in this car, just in disassembly, and here is the result. The problem that this car had was an absent display for the speedometer and the temperature gauge and the fuel gauge, which is all mounted way up here right underneath the windscreen, and had to tear this car down this far, literally this far, just to get at the Speedo assembly up here. I've never had another project that took me through so much in disassembly. And the reason for it is the way these cars are put together. Everything up here, to get it out, you have to pull out everything all the way down and to the side, beginning with the lower panel down here right as you enter the car. Never ever have I had a project to put me through so much in disassembly as this one did. It was almost kind of comical, or entirely comical, depending on your point of view at times. But I want to give as much detail on the repair of the electronics in these cars as I can. And my last video ended up, we ended up more than 2 hours in, and only then did we finally access and remove the speedometer, temp gauge, and fuel gauge assembly from up here. And literally, just refer back to that video. If you don't believe all of this had to come out just to get to that one thing, just go back to that video and watch, and you'll see why. But in this video, I'm going to attempt to repair all of the electronic assembly up here for the speedometer, temp, and fuel gauge. And it's a LCD readout that's all backlit. The gauges and all were still working, actually, if the sun shined on them while you were driving. But otherwise, you just couldn't see them because the backlights weren't working. It was strictly an illumination problem. But in servicing that assembly in this video, I'm going to go deeper into it than that, because these projects always grow as we get into them and start moving forward. So this is the second video on this 2008 Honda Civic, and without further ado, we're going to go ahead and dive right into all of this that's now missing because I removed it in the last video. See? Easy when you know how. Anyway, no, it was not easy. It was not easy at all. But anyway, at the end of the last video, we were finally at the point where I could move all this into the shop. So here we go. Welcome to the hobby shop. or we're supposed to be about tube type electronics, old TVs and radios, except for jobs on modern equipment like this always coming up. Okay, before we go any further, let me pull, if I can, a close shot of the label on the back of this for people out there who might just want to go ahead and buy a replacement to have as a reference point. Okay, and then can't really see inside the plug yet. There we go. There we go. All right. There are no screws, at least in this one, holding it together. It's just snapped together all along the back here. And down here on the bottom, beware right here, and right here. These snap tabs go to the front lens assembly, and we're going to try to leave all of that alone and just unsnap right here to break into this thing, and we'll see what we got. Okay, let's go right here, just working my way on around. And now on the bottom side, I'm going to ignore these three and just focus on these. Well, I thought I'd ignore those three, but see how plans keep changing. Oh boy. Okay, we got a little seam exposed there. I don't normally like brutalizing things any, but my gosh, what a job this has turned into. There we are. All right. Coming apart now. Oh, and that one had to go and re-snap. This is why I can never keep a good manicure, as if I ever tried to. All right, looks like we're getting in finally. There we are. There we are, cover removed. And our first look at what lies beneath. And it looks like all of this just snaps in right here, 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 and here. I want to be very careful about disassembling all of this. Actually, oh, there we are. There we are. Let me set that down okay, I guess that's what will pass for gentle. And here's the lens assembly. I'm going to place this face up because things do tend to get kind of dusty in here, and I want any dust landing on the outside and not the inside of this. So I'm going to set this aside. And now we've finally got a shot of the underside here. And I'm just handling this board by its edges. And we can see for the more electronics minded people out there, we got some, surface mount electrolytics here. And a lot of people might scream to just go ahead and recap this after going this far. But since I know all of these gauges are actually still working, I'm just looking for cracked solder joints, which unfortunately look like right here is the plug, and it looks like I'm going to have to disassemble this a little bit further to get to these terminals right here. I'm going to look for cracked solder joints right here on these terminals, and then on the back side I'm also going to look for cracked solder joints right along all of these, all the way along through here and through right there. And going to be very careful about this. Y'all, this is supposed to help anybody working on instrument clusters just in general. So this one is all liquid crystal readout, and it's all backlit. So we don't actually have any motorized pointers or anything going across on this. But anytime you're working on more traditional styled ones that still have traditional mechanical pointers running across, be sure to have a cushion or something. Don't ever put any pressure on any pointers or anything on any equipment like this, because they will most certainly get out of whack right quick. Okay, I think I found the issue here. I had to remove this backing right here, which is directly behind the front lens. And it's just held in place by a stud terminal here and another stud terminal right here, which has a little bit of a slip in it. And otherwise, this is just held on by a little bit of adhesive backing that you can see on it there. And before I reinstall this in the car, I will put a little bit of adhesive on it in places. I won't retrace everything, but I'll make sure that it's good and stuck before I put this back in the car. But just removing this gave me a better view of the terminals back here behind this main plug. And right here is where I'm convinced the problem is. Specifically, even though y'all won't be able to see it, right here on these outside two, we got 12 terminals here. We got 2 rows of 6, and it looks like we have definite cracked solder joints on these last outer 3 right here. And that would make sense because these panels are backlit by LED lights. You don't really have a blown bulb issue a lot of times on panels like this. And all of these sections, speedo and temp gauge and fuel gauge, they've all got their own backlights in it, but the problem affecting this particular assembly has killed all of them. Therefore, it's got to be in a circuit that is common to all 3. So the most likely place to find that is right here on the main plug, and certainly with road vibration and all, it would make perfect sense for that to stress these plugs right here and cause cracked solder joints on these. Also, I'm going to resolder all of these right here, and at least these last 2. Y'all will not be able to see it almost impossible y'all will be able to see it, but right here, these very last two right here have definitely got cracked solder joints on them. And therefore, you know, I'm not going to check all of it. I'm just going to resolder the whole row on each of these assemblies, along with resoldering the connections on the back side of the board for this plug here. Years ago in television and VCR work, and boy, those were the days, sometimes people would change out pack ICs, like for power supplies and power amplifiers, and they would change out, you know, they'd buy like a $35 IC and install it when the IC itself was perfectly good. The actual problem in that equipment was cracked solder joints along terminals, rows of terminals like this, and they'll usually occur within like the outer 3 or 4 on each side. Usually the center ones are going to be better, but for some reason on the outer terminals, that's where the cracked solder joints would occur on assemblies like this. So a lot of people used to buy replacement ICs for VCRs, televisions, amplifiers, and replace perfectly good ICs that were just a victim of a solder joint failure. And then of course it would work, you know, just fine, you know, by the time they finished, because they were attentive and went ahead and thoroughly, they were very careful and properly resoldered all the terminals, when actually the solder joints were the problem all the time. Okay, advanced apologies for the absolute wreck of a solder demonstration this is about to be. But a few notes. I'm using a 40-watt Weller WLC 100 soldering station, and this exact model is getting hard to find, but equivalent models to this don't cost much. But I'm using, right here, I'm using this WLC 100 with an ST8 surface mount device soldering tip. That's about all they'll fit into these tiny little terminals here that I'm going to be working with. And I am using Kester 6040 rosin core solder like I use on TVs and everything else. A note to people who are new to soldering, and especially new to soldering on things like this. This stuff right here you buy at a general hardware store is not going to get you there. It's too thick. It's just too thick of a filament. You're going to end up flooding the terminal and making a mess with this, and also it requires a higher temp to heat to the melting point. So do not try anything like this. You need to have electronic servicing grade solder. For solder removal, I'm using one of these. This is an old Edson DSO-17 solder sucker remover tube, plunger, that you just put down at the terminal and then press, and it sucks solder up. These are also getting hard to find, but that's just, you know, give you a general idea of what I'm using here. It's not going to be possible for me to really get behind this plug here and show y'all what I'm doing. So I'm going to start over here on the LCD display that is actually the fuel gauge. And if I could, maybe y'all can pull focus and see, well, zoom in and pull focus and see that these last two terminals right here are definitely cracked. You're going to have to use magnifiers to do this type of work. There's no other way. These cracked solder joints, while they will break a connection and stop things from working, oftentimes the cracks themselves are just practically microscopic, so you really have to get in and use a magnifying glass like I'm using here. You have to really get in and really look very ultra close to find these cracked solder joints. But a lot of these automobile instrumentation assemblies, this is going to be the problem you find. Not so much electrolytics. Every once in a while I'll see electrolytics that have been bad, but thus far I've been very lucky over these last, about 10 to 12 years, when the assembly is basically intermittent but still working, you know, when everything connects, just doing solder joint service. So anyway, I'm going to try to start out by giving y'all a demonstration on these two right here, and then we'll just come back after I'm finished. It's really hard. I'm using a Samsung Galaxy phone only, trying to video all of this, and what'll happen is when I try to zoom in on terminals this close, the moment I bring the soldering tip in close to the terminal, the camera refocuses on the soldering tip and totally blurs everything that I'm working on. So maybe y'all can, you know, if this is your first time or you're just not, you know, vastly experienced in working on electronics this small, maybe y'all can zoom in and slow-mo and kind of get a better idea of what I'm doing here to repair this. Again, apologies, because in all likelihood this is not going to show y'all very much of what you need to see, but you want to start with a clean soldering tip. And actually this 6040 rosin core solder I'm using is available in a finer filament than this, and I'm working at a distance here, y'all, so bear with me. Right there, it looks like I kind of flooded that one. Doesn't look like I got anything on that one at all. Then I did. All right. Now I'm going to clean both of them. It's often a two-step job because you have to first clean the terminal and then resolder it. But if y'all can see, I've got those two holes now completely hollowed out. Okay, I've got all of these unsoldered, and you'll see that it's looking like a slopped up mess. There is, between these terminals and just along all of it, you got an insulating coating that's put down. It's meant to moisture proof all of this, and you're going to have to remove it in order to do a neat and clean soldering job on this. You can see the outer edges of it right here. And I am just using a small jeweler's screwdriver. And I'm being very careful not to dig into the printed circuits. And I am just going along the surface and pushing this sticky, stringy stuff up and out of the way and plucking it off where I can. But that's another barrier you're going to hit in reworking these assemblies, y'all. This stuff right here is just, it's common on appliance boards and automotive assemblies. And you got to get it up and out of there. You got to have it up and out of the way. You're not going to get a good solder joint if you leave that stuff on there. You got to get all the terminals unsoldered and thoroughly clean out all of this mess right here, because you will not get a clean connection with it in place. So be prepared to do that. Do not use a sharp razor blade or anything. Like I said, just this little jeweler's screwdriver is what I use, and I'm just being very, very careful going over this stuff to just kind of let the blade just kind of dig in just a little bit, just enough to get all this coating out from around these terminals before I resolder these. Right here we've got a really, really good shot of it. Look at that, if y'all can see it. And I've got to clear that out the whole way. I've got to clear just kind of, look at that. Oh, isn't modern electronics fun? But anyway, I'm going to continue on like this, but you'll notice it's really cleaning up pretty well so far. Right along here, where it's well away from where I'm going to be working, I'm just going to leave the residue of it right here. I just want it cleared from right in here on these solder pads right where I'm soldering. If it's, you know, where it's further out, I'll leave it, but I've got to have it clear right here. If you're like me and you've been doing this as long as I have, you kind of develop a feel for how much pressure you can put on these boards with a tool like this before you're damaging or risking damage to a printed circuit. Anybody who hasn't done this before, by all means, find some junk boards and practice before you tackle something like this for your automobile. I've just learned over time how much pressure I can use basically to get this stuff started. And sometimes, I mean, I'll leave little marks and all and everything. Hey, as long as they're not, as long as the printed circuits aren't damaged or the conformal coating on the board damaged very badly, you're okay. You're all right. But this is just another aggravation of modern electronics, and the reason I don't hardly get any antique work done here lately. So I'm just going to keep after this. We'll see how it ends up. Here we see I have finally gotten through removing that insulation. This is the fuel gauge, and right on across here are the solder pads for the speedometer readout, which I've actually already removed. And over here are the pads and terminals for the temperature gauge. Removing the speedometer readout was necessary to access the terminals for the back of the main plug here. And a quick note about removing these: make sure, as you can, I'm trying not to do this in shaky vision, y'all, but make as certain as you can that each terminal, before you go to remove any of these assemblies, is totally free and clear, not bound by solder, and ready to come out. Make sure every single one of them is clear. Otherwise, you're going to try to pull that assembly, and you're going to snatch a solder pad, and you're going to end up with printed circuit trouble. And don't delude yourself into thinking that I got this done quickly. This took about 3 hours. If you're wondering what kind of labor I charge doing this for people, it's a couple of $100 at least. Nobody gets this service off on me for free. I have to be competitive against the price of new assemblies. And at the same time, I've got to make money. But this whole process of just removing all of this crap right here, this is about 3 hours work, and it's the following day. Now that I've finally got it done and got the speedometer assembly removed. All of these terminals right here are only for the LED readout, LCD I mean. All of these terminals are for the LCD readout and have nothing to do with the problem that we're chasing here of lighting. The backlighting is on the opposite side of the board. Here are the actual bulbs, if you will, actually LEDs that provide the backlighting for the speedometer readout. And these double-sided boards, you'll notice they have a lot of places in them, like right here. That's because the wiring from one side has to actually connect through the board to the wiring on the other side. So if you see any corrosion around places like this, go ahead and inspect and clean that. And if you end up having to repair one, usually you see those little holes there. You can take like one strand of just one single strand of electrical cord or other type of automotive wire, just a single strand of it that'll fit through these holes. And what you want to do is just solder it on one side and solder it also on the other side. But that's the way to repair the through eyelets, where one side of the printed circuit board connects to the other side of the printed circuit board. These double-sided boards can be hell to work on. I'm not going to lie about it. That's the reason, like I said, actually, a job like this for a customer, if this wasn't my mother's, I'd be charging about $300-something for this, just for labor. But here are the actual LEDs that provide the backlight for the instrumentation in this 2008 Honda Civic. And I was very careful when removing the speedometer readout that you see I was extremely careful to keep all of these straight. I just gently laid it to one side right here. Lining all of those back up with these holes becomes next to impossible if any of them get bent. So be extremely careful when removing any of these LCD readout assemblies, which is in the 2000s era probably what you're going to find. I haven't ever seen one that's got just straight LED readout, but I know they're out there. I've never worked on one before. This is my first time actually working on one that's actually LCD. Actually, I've had other people to inquire, like for Chevrolet Impalas and such, that had backlit LCD assembly readouts and all on them. And I told them, if you remove it and bring it to me, I'll service it and then you reinstall it. I never heard back from them. In fact, my next door neighbor actually sold hers rather than even deal with it after that, just because of instrumentation failure. No speedo or other gauges in that Impala, and gone, sold. Let that be somebody else's problem. But here they are. And working on one like this, I'm going to thoroughly, with a magnifying glass inspect all of these. I need to get me some of those magnifiers that I actually wear on my head, because the time has come since I'm doing work like this now for people. And I said I wasn't going to be doing customer work this year, and that's actually true. But at the same time, this is my mother's car, so here we are. Just generally speaking, a couple of the barriers that people have to overcome working on stuff like this. One, you have to know how to solder, and you have to know how to remove solder. I use this Edison, this old Edison. I've had this thing about 30 years now. DSO 17 solder sucker. This is actually something that, just doing it one-handed. It's got a plunger inside here and a static free tip on it. But you cock this sucker, and it puts that plunger down there into the bottom. And then when you snap to release it, you saw that come up. It creates a brief suction that just sucks the solder up. That's all this is. And I recommend this over any kind of powered vacuum desoldering iron, because I have seen many circuit boards really just ruined by people using these electric vacuum desoldering tools. Usually what happens is the desoldering tool, they get it on the pad and they heat it up, and then they hit that suction, and it starts that strong suction, and the tip is actually stuck to the solder pad. And then when they go to pull the tip away, it peels up the printed circuit. So soldering skills are something you have to master before tackling a job like this. But the other fear that people have is just touching this. You've got to get used to your work environment. You've got to get comfortable handling stuff like this. Get over that fear that you're going to shock it and ruin it. And it's going to be just, oh, it's going to be ruined. It's going to be ruined. You've got to remind yourself you're working on something, like in this case for a 2008 Honda Civic, and it's now 2025. How much good is this in the car when it's not even usable? You know, effectively, it's already ruined itself. It's already ruined itself. I'm not saying don't use due caution and everything while handling it, and don't even do all that stuff that I did just a moment ago. Do use due caution, treat it with due respect while you're handling it, but get over that fear that you're going to ruin it just by handling it. And people say, whoa, what about the dud value? What about the dud value? Let me tell you something. Personally, on stuff like this, I always deal with O'Reilly Auto Parts, and they're wonderful people, and I love them. I have never once turned in anything at any auto parts store, whether it's O'Reilly's or Advance or AutoZone or Napa, where they have ever done like a thorough inspection before allowing me the dud value on stuff like this. By all means, try not to destroy it, but, you know, try to fix it. But if it gets ruined, if you ruin it, you got to learn. You've got to learn somehow. And the only way to learn is by diving into all this stuff and just doing it. You've got to dive in and do it. So there's been a lot of talk, especially back in the late 80s. They did a lot of talk about surface-mounted devices and everything. And, oh, the static electricity from your body is going to just kill all this stuff. The moment you touch it, you ruin it. Look, y'all, I have repaired televisions galore where I have had no choice, just as right here, other than to handle and touch this stuff. You've got to handle it enough to work on it. You've got to. And they used to sell, and I guess still do, a whole lot of, like wrist straps and everything, and a grounding pad for your bench and all, to keep your body stack electricity level equalized to what you're working on. If you want to do all that, fine. If you want to do all that, fine. So much the better. But personally, I like to be free to move. And as I said, if I fail on this, I said it at the close of the last video, you'll know it. You'll know it. I will own up to if I ruin this trying to repair it. This is a real channel. We don't always succeed. And I will absolutely own up to this if I ruin it trying to repair it. But you've got to get comfortable handling all this so that you can work on it. When you send it off somewhere for somebody else to do it, how do you know it's not somebody like me who just, handles it all like this, without any kind of special equipment or anything? And then you buy it as a reman part, and you have no clue about its history. But do by all means be extremely careful, because this one right here is the original one to this 2008 Honda Civic, and they're only pristine, factory fresh, and untouched once. So you can see I have tried very, very excruciatingly hard to be careful, and you can see here also that I have marked it in places while using this tool here to get all of this protective coating off. It's marked, but look at it. If you really look at it, you'll see that those scratches are just right there on the surface of the conformal coating of the circuit board. They are not penetrating all the way down into the bare copper, except maybe, in a few places, but nowhere in this have I severed any of the copper conductors of the printed circuit board. You're not going to work on a printed circuit board without marking it. Forget that. That is next to impossible. You're going to mark them every single time. Get used to it, and determine yourself that it's not the end, and just try to be as gentle as you can, and don't mark them any more than absolutely necessary. See all these scratches? They're mainly just on top of the conformal coating. You don't see any copper or anything except right down here at the solder pads themselves, where I had to get in there with the soldering tip and work some. It's absolutely unavoidable, that you're going to mark them some, but you've got to learn to start trusting yourself on tiny, tiny electronics like this. And this is actually quite large compared to a whole lot of what's probably out there today. As far as my procedure on getting everything to this point, I didn't really go into detail because with each job, it kind of varies. On this one, all of this stuff was thin enough, just a thin coating across all of this. And once again, see, all these terminals are free and easy now, where this is the fuel gauge. They'll slip right on out when I get ready to remove this. Anyway, on this one, it was possible for me to, because the coating was so actually better than paper thin, I was actually able to use the soldering iron to go ahead and unsolder all of these for the most part before I really started my cleaning. On others, I've done some for international school buses and all, where it's been heavier, and removing all of this stuff right here had to come first. But my procedure varies with each project, but Basically using the desoldering method I showed you earlier to clean out around all of these terminals. That will go ahead and cause this stuff to basically bubble up. And that gives me a good place to start, right there, right at the terminal, getting it to pull up and getting it cleared off the board. So I started on this one by desoldering and, by adding solder and then desoldering, and then coming behind all of that with this, just to gingerly and as delicately as possible get all of this stuff right here removed. Anyway, I don't recommend you use solvents. The reason I go and use a manual method like this is because solvents, you never know but what. Solvents might cause more damage. They might actually weaken the glue holding the printed circuits to the circuit board. They might actually cause this stuff to actually kind of melt and smear all over the place and create a greater mess. I've had bad experience with solvents in the past. So my personal recommendation is just go ahead and bite the bullet and do it the hard, difficult, manual way and spend the time to do it, and know that this took at least 3 hours, and it's the following day now since I started all of this, all right? Notice I did not remove it from around any of these surface mount LSI chips. I just got it removed from the solder pads right here where I'll be working to get all of these terminals right here resoldered properly. That's all that I've done so far. And removing the speedometer assembly, when I flip this over, you'll see actually cleared the way for me to go ahead and clean around behind the main plug. And you'll see that's kind of scratched up too. Hey, you're not going to get it perfect. And if you get into a hurry, little accidents like that are going to happen. Do not sever the printed circuits. Anyway, interestingly enough, once I got the speedometer removed, they did not have any of this crap right here actually over these terminals. So as far as how important it is, to have it back on there, use your own judgment. Once I've confirmed that all this is working again, after I get it all finished and try it in the car, I'll probably go back with something, to protect them. But I'm going to make sure it's all working again before I do that. But you've got to get comfortable in your service environment. You got to get comfortable in the environment of what you're working on. And on this is the first step on that. My time on YouTube has taught me that it is basically impossible for me to pull off a successful soldering demonstration on a printed circuit board like this, but I never learned my lesson, so I'm going to try. Once again, I'll try. A quick tip about this. Sometimes at the very tops of these terminals, there will be a little debris or oxidation that will really try to gop up your solder as you're trying to solder on things like this. So what I'm going to do is very delicately snip off the very tops of these terminals. I'm not going to snip them down close. I'm going to just snip off the very, very tops of these terminals here. And hopefully they'll create a better path for solder flow to envelop the entire terminal. As far as the tools I'm using, this WLC 100 Weller soldering station is not temperature regulated. Experience over many years has just taught me It's kind of oxidized right now, but what I'm looking for, what I go by actually is smell and look of the soldering tip. This is a 40-watt iron, but I'm not going to run it wide open because I'm not trying to absolutely just roast everything. I'm looking for the proper solder flow temperature. And actually, I want the tip of the iron to be kind of bright yellow, verging on bright yellow, and no hotter than what would make it appear dark orange on this. And basically, the tip of the iron just kind of has an odor to it when it's at the right temperature to proceed with soldering. And that's assuming all of these terminals have been properly prepped. And other than using that jeweler screwdriver, that's all I've done so far. But I am going to snip the very tops of them off before I proceed to solder. And that'll get a nice, bright, shiny surface right up at the very tip top of the terminal. And hopefully, a lot of times that'll aid in solder flow. Anyway, a quick demonstration of what I expect will probably happen if I don't do that is it'll probably kind of go rubbery and get all gopped up here. Let me clean that tip one more time. That's looking good to me. And we'll try this one. A lot of these pads right here are probably through outlets that continue on through to wiring on the other side of the circuit board. So I'm going to linger on these just a little bit longer than I otherwise would. Hey, that one actually went okay without even being snipped. Wow, that's perfect. All right, let's see about the next one. It can't go that way the whole way. No, I got a little, yeah, that one right there, see, it's going to be, this one's going to be a booger. So anyhow, I got the desoldering tool prepped and I'm just going to unsolder that one right quick. And I'm going to proceed just with a pair of dikes right here, just to carefully snip the very, very tops of these studs off. Just enough to get them shiny on top before I continue with this. All right, I've got 1, 2, this will be the third. Right there. Didn't quite come off. I'll have to continue this off camera too probably, but see how shiny that is? That right there will help with solder flow. So just doing this is another step toward a neat soldering job on this. Just know that before we come back. There we are. Let's see if I can get that centered just a little bit better. I really hope these videos help a first timer somewhere. And notice down here where the speedometer cables go through, we don't have any through eyelets here down along this. So these will be exclusively on the other side of the board. But if you can see, and I can see working here, okay, that's good. Again, I'm allowing for through eyelet connections, so I'm lingering a bit longer than I otherwise would. And you see, even using a surface mount device tip, for this iron, really, just how close all this is. There we go. That looks good from a distance anyway. So much of soldering is basically, yep, I can see right there, that one right there tries to have a resin block in it. It's going to be pretty rare if you do a lot of soldering on stuff like this to have one to go absolutely right the first time, and probably I'll have to retouch some of these even after I've done all this for the camera. But you see, just snipping that top off basically gives me a shiny surface right at the top of the terminal to start with. Yep, everything's got to go haywire. Just can't hardly do soldering on camera here. But I'm trying. I'm not going to worry too much about a solder splash. Like I said, I'm saving the cleanup for after all of this is done and I've inspected it all off camera and really sure I got it all right. See, that's how easy it is to short between terminals right here, y'all. I might have to change angles slightly. And this board's just laying here loose, so I'll take another look at all of these before I okay them, and doggone it. If you do a lot of soldering work, you'll notice how much solder you end up wasting. Just on repeated attempts on stuff like this. Are we still centered? Alright, pretty well. Okay, from about a foot away that actually looked pretty decent, but we'll see. I didn't need glasses before 2014 actually. So those two right there just are bugging me. They're bugging me. Got to clean that out too. Got to get used to your work environment. Got to get used to the environment of what it is you're working on at any given time. Yep. There must still be some of that insulation down in there causing all this to go rubbery. Very hard to solder on camera. Alright, that looks decent from here. And then I short those two together. And it's time to clean the desoldering tool, obviously. Alright, that one finally looks decent from here, and that one does not. And it just screwed up the previous one, so here we go again. This is all in it, y'all. This is all in it. Alright, that looks decent. And that one right there still being a booger. So we'll try it again. and again. All right, let me look at it all off camera now and see how I did. Not as immaculately perfect as what I would like, but that doesn't exist anywhere in the real world when you're working on boards like this. But look close, there's no shorts between the terminals. I admit it looks close right here between those two, but that's as good as I believe it's going to get. The main thing I'm looking for are any hollowed out places or signs of bubbling or anything in any of these, which would indicate a resin block from solder flux and all. And the solder flux I ended up removing, just chipping it off gently, again with a jeweler's screwdriver. I have used flux off before, but like I said, I'm trying to avoid chemicals on this, so not seeing any shorts here. And flux is removed from between the terminals, so I believe this right here will actually pass. I ended up getting a little too hard on the board right there. Kind of got through the conformal coating between these two, but I hate that. But like I said, you're not really going to get these jobs immaculately perfect. You've got to learn to trust yourself, and just ultimately you have to hope for the best when you're trying to reman some of these assemblies. I could probably try for hours and don't know that I would ever really, that it would ever come out any better than what it is right now. So we're going to try this and see how this works. So now it's time to reinstall the speedometer display and get to work on that. I've got to be very careful. I'm not, what y'all see, I'll find out later, but I've got to be very careful to line up each and every one of these pins and their respective holes to get this back together. Don't know if I can even do this on camera, but again, you know, I've never learned my lesson on something, so I'm trying. Doesn't look like I'm going to be able to do this on camera, so back in a mo. And it turns out, not at all unpredictably, that I can't even get this sucker back on here off camera. 36 terminals that have to mate with 36 holes, and you can see I've already been trying here for a couple of hours, and if even one does not align absolutely perfectly to fall in, it doesn't go. And there's been more than one not wanting to align. To give you an idea of the kind of clearances I'm dealing with here, I have here a 1/32 drill bit, and a 1/32 drill bit will just ever so barely go into one of these holes without messing up the solder pad on the other side. But it's been a couple of hours, and those who predicted disaster when I remove this, go ahead and give yourselves a hearty pat on the back. Even laugh if you want to, because you weren't wrong. But we get into jobs like this, and yet we've still got to finish the job somehow. And a 1/32 drill bit, it will just barely go into the holes for the terminals on this LCD display for the speedometer readout. Now, me trying to be thorough, I went ahead, and I removed this. As I've said before, you follow in my exact footsteps at your own risk. I removed this to gain better access to the terminals on the back side of the main plug right here, and also to go ahead and inspect the LED lights that provide the backlight for the Speedo assembly. But you follow in my exact steps at your own risk. So let's see if I get that 1/32 drill bit. Turn this around just to give you a real good idea of the kind of scale I'm working with here. Look at the relation, look at how much clearance there actually is between these. That's just with a 1/32 drill bit. Let's see if I can get it on here and just kind of give y'all a better demonstration. Right here, y'all, these are the kind of clearances that I've got to work with here. A 1/32 drill bit will barely go through each terminal hole, and you can see that using that same bit, there is just practically no leeway between them. All right. Well, I got into this, so I'm bound and determined to try to finish it, so I'm going to have to fall back on an old, seldom used, thank God, service technique here for circuit boards. I'm going to have to try to wallow out these holes here just a little bit to try to get just a little bit of a guide for all of these terminals to slip into. That's what I'm down to. If we look right here, right now this is the situation we got. We got 36 terminals, 36 holes, and yet if they all line up precisely and just drop right in, easy peasy. But what I'm going to have to do, what I'm going to have to try, is to wallow out each one of those holes with as close a clearance as there is between them to just kind of create a trough here for each of the terminals to kind of drop and slide into and then drop down and come out through the solder pad underneath. That's what I'm going to have to do. There's practically no room to work, but at the same time, again, thankfully, there are no printed circuits for any of these terminals on the top side of the board. It is all underneath. So I am going to try to drill out each one of these holes here just to provide just a trough there to kind of guide these terminals in where they are just ever so slightly misaligned so that they will go all the way through and come out through the solder pad on the printed circuit side of the board. I'm not going to go all the way, I'm not trying to go all the way through the board. I'm just trying to provide a guide for each terminal to drop into as I try to reinstall this, to let each one just kind of fall in and have just a little bit of a trough to guide it down to the solder pad. If I drill all the way through the board, I'm going to mess up the solder pads, and basically, as small as all this is, the board will be ruined at that point. But that's what I'm down to trying. There's no way I'm going to be able to even attempt it on camera. So I'm going to have to let y'all just see the end result, however this works out. But the lesson here is two things. One, if you get into a jam like this working on tiny printed circuits, it's not the end. Don't think of it as the end. And the other lesson, well, don't follow in my footsteps precisely if you don't want to. There was probably no need to take this off, given that the problem was probably down here, but I'm into doing very thorough inspections, so I took a chance here, and now I'm paying the price. But don't give up. Don't give up. You get into a tight like this, and just going to have to think about it and give yourself a chance. Try everything you can to get out of it before you give up. So anyhow, I've got hours of work ahead of me, because this is going to be very excruciatingly close precision work I'm doing here. But hopefully I succeed, and there is still hope for all of this to work again. All right, here we go. My. Well, I'm still at it and taking my time, and so far so good. But this is about as terrifying as work I do here gets. Like drilling teeth. That's about the only thing I can imagine that would be more terrifying than this. There's so much at stake. Yeah, drilling my own teeth would be more terrifying than this, but that's about the only thing I can think of. Maybe I could use this video to put in a plug for Dremel. About years ago, I used to do this with a regular drill and drill bits. No reflection on Dremel if it doesn't work out, but all right. Onward and downward. Okay, let's see what we got. Locking my own light here. Believe we can still see the solder pads intact. Looking through from this side. Let's discover the other side together. Looking good. We've got some phenolic dust. Let me get that 1/32 drill bit now, and what I want to do is make sure that all of these holes are good and clear. This is about as far as I dare go. I'm using the blunt side, by the way, of this 1/32 inch drill bit to just go through here. I'm not using the side that has teeth. Just gonna go hole by hole and make sure every one of these, all 36 of them, are clear and on down the line. I don't normally want to take my viewers along for the ride on stuff like this, but since this project has turned so devilishly deep, and do-it-yourselfers out there might want to attempt something like this, I want to show, at least give a representation of everything I do here on a job like this, because everything has got to be basically, this one's a little bit tight. Let me wiggle that a little bit. I want this drill bit moving absolutely free through all of these solder pads, and I'm being very careful to feel whether or not it grabs when I'm moving it in and out, because I don't want it to pull the solder pad loose. At this point, that's the last thing I would ever want to have to try to demonstrate in this video, is how to repair a broken solder pad. Best policy, don't F them up if you can help it. Just soldering on them, on stuff like this that really was never meant to be reworked. That's abuse enough on a solder pad. And I already know, because all this is so close still till there's just no way I can demonstrate trying to remount the LCD display on this video. There is just no way. That one right there wants to grab a little bit. So you see what I'm doing? I'm just kind of wiggling this around just a little bit. I'm not pulling on it or pushing it in or out. I'm just going around with it some. This one right here don't quite want to slip into. That reamer bit has left some small little pieces of phenolic probably in some of these, so there we go. There we go. Last one. That was all 36, wasn't it? Y'all have to tell me, I don't count. But anyhow, get a good kind of tight shot here. As tight as I can get. And looks like so far I've gotten away with this little operation. I've had to haul out a 500 watt halogen light back here behind me to light my work area, but there we are. They're not reamed out a lot, just enough, and I might have to retouch some of these before I get that remounted, but again, same 1/32 inch drill bit that I was using before, and that'll give you an idea maybe of how much I've actually wallowed these out. This would not be possible if there were printed circuits on this side of the board over here. I'm very lucky that on all of these there are no printed circuits for the LCD display on this side of the board. They're all on the back side. So now let me clean this up and see if now I can spend like a couple of hours and end up with the LCD display mounted again. I need my head examined for even attempting this on camera, but here goes. Oh boy. Come on, come on. Come on. Wow. Okay, let me see if I can get this snapped in place. I hope it doesn't lose focus, because there is no way I'm about to restage this if I pull it off. Oh, come on. Oh, boy. Don't come out, don't come out, don't come out. Yes, you fell out. All right. Went for me once. Do it again, do it again. Come on, one more time. Give me my money shot. Can't believe I got away with it twice. Okay. Got a little guide hole here I've got to ring. Two actually, here on the back side. One right here and another one right here. Come on. Okay, snapped on one side. The side that has the slip has actually come through. All right. What about the other side? on. Just trying to work through a camera sucks. Was that it? Snap there. Snap there. Okay, and while we're zoomed in, have I gotten away with it? Oh, I can't believe that. I cannot believe I actually seem to have gotten this done on camera. Did I? Looks that way. Did I actually pull this off? Look at that. Woo, would you look at that? Snapped and secure. Snapped and secure. Oh, yes, yes, yes. Oh, and a few hours ago I was thinking I'd ruined this and that ever getting this back together. I especially working through the camera, I didn't think I'd be able to do this, y'all. But look at there, every single one, and not a single solder pad lifted. Not a single one. I'm going to have to go off camera now to dance a little jig. My victory jig. All right. Round of applause, please. Thank you. While we're at it, go ahead and give a big round of applause to my still relatively new Dremel stylo. That's the tool I was using a while ago. Just a Dremel with the most tiny, minuscule reaming bit on it that I've ever seen. But yeah, I bought this just a little while back, a few months ago, and I am officially now sold on it. I never would have gotten this back together without it, y'all. So call it a shameless plug for Dremel, but if you're going to be doing PCB work, you need to have a tool like this, and I now officially recommend this one. As Martha Stewart used to say, it's a good thing. While we're on the subject of tools, a good bench vise with changeable heads, that doesn't go amiss in this type of work either. This is a PanaVise bought about 30 some odd years ago from MCM Electronics, for those people who might remember them. So sad still that they're gone. As long as MCM was around, electronics work could be so easy, but anyway. Little blast from the past here. Okay. What foolish chance can I take next? Let's see if I can pull off a desperately close soldering operation on camera. That's right, Pierce. Just keep on trying your luck. Don't stop until you ruin it. Just keep on going until you have totally laid ruination to a job you were so close to pulling off. I hope this isn't blurring for y'all, but oops. Okay, that didn't go. Where's my solder pump? Okay, let's try you again. What I want to pride myself on this channel, y'all, is not doing like a lot of other channels do and basically giving y'all before and after shots. I want people who watch my videos to have a real sense of the reality of doing electronics work. Looks like I shorted those two. I'm looking at a distance, but... And of course, I'll have to go over all this again once everything's completed. Yeah, I'm looking through the camera now and I can see where I screwed that one up as well. So, oh boy, here we go. All right. How are we looking now? All right. Cleaning my tip again off camera. That's the only appropriate place to do it. And y'all have a much better view of the work I'm doing right now than I do. I'm basically working by feel, trying to do all of this. Even I can see that one didn't go right. That looks kind of suspicious to me. Yep, very suspicious. Don't believe I'm going to be able to do this on camera, y'all, but I'm trying. The things I do, the things we all do for YouTube, right? So, here we are. Nah. It's not going to work for camera. Some people might be screaming, for all I know, that, hey man, you're unsoldering perfectly good solder connections, but y'all, I'm working from a ways back here, so bear with me. But people considering doing this work, they need to have a real idea. I mean, a real, true idea of the kind of heck that goes into it sometimes. So, I'm not going to be able to do this on camera. And y'all, I'm so close to having this thing ready till... I don't want to screw it up at this point, so I'm going to finish this step right here off camera, if y'all don't mind. And once again, I'll let y'all see the finished result. I'd like to be able to show y'all the whole thing, but I just cannot work on stuff this small from as far away as what I'm working. So I'll be back once I get this thing fully reinstalled, okay? And of course I can't resist. So here I am trying for the camera again. Because on YouTube the camera is all. The camera is off. Even if it means I screw up a project I am so near successfully completing on YouTube, the camera is off. I'm one of those people that I just flat out cannot let go of a challenge, even when it would make perfect sense to do so. Let's see, how am I doing so far? I think I'll actually pass. Am I still in focus? I can't believe it, I actually am. I've gotten the speedometer resoldered finally, and the gas gauge resoldered finally. This is the temp gauge, which I had also removed for a reason I'll show y'all later. Well, I don't know if you can see it, but it's this large transistor TR3 right here. That's that's the reason I took the temperature gauge off, to give me better access to that, because the terminals on it had very noticeably cracked solder joints on them. Enough so that it might be a contributing factor to the problem, for all I know, working without a schematic, or might even have been the whole problem. Given that this uses LED lamps instead of incandescent, not impossible that a transistor, if it's a regulator, and the circuit of the backlights might have been getting hot and causing the LEDs not to light. Gosh, I hope all this is going well, because I'm still working from a bit of a distance here. I'm kind of at odds with my tripod, trying to, in these early videos, find a way to position it where I can actually work and show the work I'm doing as I'm doing it. And the tripod, the legs on it, are always just ever more blocking me. So I end up trying to do stuff like this from a distance, and that doesn't fly too well. I see a little spur on that one, so let me re-hit it. I'm going to try to do this uninterrupted, so that by the time I'm finished I can do a continuous shot, and we'll inspect this work right here together, all right? And another spur. Sponge for my soldering iron's getting kind of full, so it's getting tougher to keep the tip of my soldering iron clean. Okay. But it's looking clean to me right now, so here we go. One more right here. All right, one more right there. Can I get a third? Maybe I did. Alright, that one actually looked, and when I did it, actually felt right. So did that one. I wonder how many of these I'm actually shorting together, talking about they feel right. Okay, have I only got 2 to go? Well, I'm looking from a distance, but looking pretty good. All right. 1 or 2 more final cleans of the soldering iron tip, and let's see. Can I do it in just 1 more cleaning, or will it take 2? All right. First, let me cut into the shot with my magnifying glass and give this a general look. And well, I don't see any of them shorted together yet. I see some solder flux and a solder splash or 2 that I'll have to clean off, but actually that's a little bit more of that insulating gunk. Isn't it? Seems to be. And I think I see a solder splash, just a tiny one right here. There we go. There we go. Some people might cry foul that I think I'm actually going to leave the solder flux in place. You can buy stuff like flux solve and everything to remove solder flux, but I'm starting to feel like I've put this board to enough punishment already, and I don't see where the solder flux is going to really create any usability problems here. These are mainly power circuits. They're not really signal. So not really high frequency signal, so I'm believing that I can probably get away with leaving the solder flux in place on this, but we'll see. If I got another little solder splash right here, is that what that is? Yeah. All right. Did I get away with pulling off, trying to pull off a real close soldering operation on camera? We'll see. Let me get her unclamped. Over here on the table. And we'll do a final inspection together. All right. Get backed out here. I'm a little bit ashamed of that clip a while ago where just, wow, did I was shorting everything together, but this right here that I just did, yeah, that's a little copped up right there. But all in all, not shorted. And if we get around here, Here is the Speedometer LCD submitted for y'all's approval out there in YouTube land. And here is the fuel gauge, which I went ahead and did off camera. So let's really look at them. Got some solder flux that I think I will try to chip off of there, but I'm not seeing any too shorted together. And they do actually look pretty firmly soldered to the solder pad. So there we are. And again here on Speedo. Light reflections are making all this look mighty ugly to me. But anyway, let's turn it around. And here we go. This will be the fuel gauge, now with it facing like this. And then, where's it at? Come on. There it is. Speedo again from this angle. The plug's kind of blocking me some, but I talked about earlier leaving things looking untouched as you can. Y'all, on boards like this is about as untouched as a lot of them are going to end up looking. But anyhow, I pulled off a close soldering operation for camera on YouTube, so I'm pretty happy. This TR3 right here at the temperature gauge, you want to look very, very close at the 3 terminals on it. And they're blocked when we come around to the other side. There they are, right there. Right there up underneath that lip. They're easy peasy to resolder. I probably should have done that on camera, but these 3 were most assuredly cracked and showed signs of heat. So went ahead and did those. And then over here we've got an IC that actually I'm going to leave alone because I don't see any cracks in these. So I'm going to leave those alone. But other than that, we're getting mighty close to having this thing ready to reinstall. At least try out. Okay, here's the completed job on this assembly, y'all. Solder flux removed, and I removed it all manually using this jeweler's driver because that forced me to go between the terminals and gave me a good opportunity to inspect my work as I went. And also I just couldn't stand having all this with a bunch of solder flux on it. No, of course I couldn't have that. Camera's not picking it up very well, but one more time, here's the LCD display terminals for the speedometer. Here are the ones for the temperature gauge. And here are the ones for the fuel gauge. Every angle I look at, this is just basically telling me it's about as good as I'm going to get it. No way to get one looking brand new, and of course, anything like this you work on is going to show signs, but to me, this is actually looking very well. So, I went ahead, IC3, as of course I was always going to. I went ahead and resoldered those and defluxed those terminals, whether they needed it or not. So that's really just about it. At this point, this thing's either going to work or it's not, and if it doesn't, I'll just go ahead and order and install a replacement for the whole assembly. For those who are concerned about the surface mount electrolytics on here, I am going to leave them because, again, this was an intermittent problem. Sometimes, every once in a while, it'd still come on and work. And when everything connected, this was still working fine. So I'm not going to worry about these surface mount electrolytics. But for those who are interested, we've only got two here on the back side and two here on the front side. And if you want to have them on hand going in, here they are, as they're numbered on the board. C352, which is this one right here on the back side, is a 10 microfarad at 50 volt. The only other one on the back side here, C22, is a 33 at 25. Both of these here, and this one right here, just hid below the speedometer LCD readout. This one and this one are both 330 microfarad, but this one right here, C2, is a 330 microfarad at 25 volts, and this one right here is a 330 microfarad at 6.3 volts. But every way I look at this board now, it looks to me like I have done all I can do on this. So we've gotten a pretty good lesson in on the problems in printed circuit board work, going over this, but now it's time to find out if I've actually accomplished anything, or if I've ruined it, or if it's all still the same. It's time to try this thing out. All right, there we are. Now we're coming up on the moment of truth. I'm going to stick the key in, and oh, look at there, look at there. I see a backlight. Only on the speedometer so far though. But here we go. Switching on. Hey, look at there, look at there. And our wipers are going. We have got fuel gauge, we have got speedometer, we have got temperature gauge. All right, okay. Let's go for a ride. Tack tachometer and everything's still working. Oh yes, yes, yes. Oh, this is what I love. Yes. Oh, this is when it all becomes worth it, y'all. All the things we go through. Reverse. And actually, this car's got one of those, I'm gonna have to get back with y'all. This car's got one of those high rear windows that basically just won't let you see shit. But look at that, we got lights. Y'all, we have got working instrumentation again. Temperatures climbing, just right for this time of year in Georgia. That's what the temperature does. And you know what? I believe the air conditioner is actually still working after all of this. Oh, this is too good. This is too good. After everything this sucker has put me through just to access this and then to repair the board, she's a working. But are all the segments working? Well, you know what we have to do to check that, don't you? As Doc Emmett Brown said, and Back to the Future, when this baby hits 88 miles per hour, you're gonna see some serious... There we go! You know, actually, for a Honda Civic, this sucker right here will scoot. I mean, it'll just flat out. Oh, yeah. Beautiful. Beautiful. Alright, time to take this thing back and put it up, all the speedo and all back together. And then we'll try it again. I am loving this. Loving it. Woohoo! Oh, we've even got turn signal, look there. Hazard! Maybe I should leave those on. Partially disassembled car going down a Georgia road. Alright. Okay. All these hard jobs, results like this are what make them worth it. I've got the overlay stuck back on. And like I said earlier, I didn't do a full retrace of everything here. Right here below the speedometer, there was a nice little plastic tab there, just on that LCD display. So I just put a little dab of our good old friend Amazing Goop on that, and just pressed it down right here after making sure I had it in the locator tabs right here. And it's been sitting like that for a while, so now picking it up by the overlay, as you can see, it's thoroughly stuck, but still trying to stick back on its own up here at the top actually. But like I said, I didn't mess around with the outer edges or anything. All it needed is just something to hold it right there, and so a little goop right there and job done. Also, regarding the question of all of that aggravating sealant that I had to remove from this earlier in the video, I am going back and I'm replacing it with something, and you can kind of see it right here. And you see it's totally opaque. But what I'm using is GC Electronics Corona Dope. And right there is the part number for it. Don't mistake it for this stuff right here, which is basically liquid tape. You might try using this, but I generally seldom ever actually use this. My go-to for everything like this has become the GC Electronics Corona Dope. Part number 10-4702. It goes on pretty thick, and then it just kind of settles down as the solvent evaporates out of it. This stuff right here, I carry over into this from television work. It's actually formulated to seal the high voltage systems and traditional televisions that have picture tubes to prevent high voltage arc over. It's got a very high dielectric strength, and it's made actually to seal RF voltages, and it's very, very good stuff, and it became my go-to for jobs like this as well. But this right here has been sitting for a while, so I'm about to apply some more of this to the back side here. You'll notice I've got this sitting on a shop towel. That's just to protect that overlay and everything from getting scratched like it might on a hard surface. But this stuff right here, it goes on pretty thick, and it's actually not something that's going to cooperate with application on camera very well, because you see, get it out and look at that. That's the kind of material I'm using here, y'all. And it's very, very stringy, actually. But really, really just good stuff to use. And I'm just going to try to apply it right along these terminals here, right where necessary, and then just sort of try to use the brush here to sort of just dab it in between them. It doesn't look like the neat, clean, finished job, you know, that people would like to see, but it works very well. And whether or not you actually use anything at all to try to reseal all of this is really just kind of up to your own judgment, because if you look, you'll notice that a whole lot of the board just doesn't have anything on it. You'll see that it had some around this LSI chip. But so many of the connections on these boards are just bare anyway. And have, you know, they never had anything. So it's kind of down to your own judgment, you know, how important it is to actually apply anything to go, you know, to reseal all of it. But I like to do it just in the sense of being thorough and that way, you know, I can just know in my own mind, you know, that I did actually put something back. And I'm not going over the whole board, of course. I'm just trying to put it right where it's needed. But I've never had this stuff, you know, interfere with the operation of anything after I've applied it. And to its credit, as sloppy as it ends up looking, it does remove a whole lot easier than that original stuff that this board had on it. And you might want to try using something else, but this is just my go-to. When I find a chemical or, you know, anything that seems to work, you know, across different genres of electronics, I just don't stock, you know, like a separate kind of sealer, you know, specifically for everything. And applying this stuff is a last step after I've made sure that everything is, you know, going to work. I don't want it just across the terminals. I want it kind of, you know, so I am slopping it up some. I want it to be down, you know, in between the terminals. And it is over time after you apply it, it's self-leveling. So just for people who had a concern about, oh man, he took all that stuff off of there and then he did that soldering and he never went back with anything. No, I do go back with something. RF circuits and televisions are a lot lower current than this is, but I mean, they're down, you know, literally milliamps, which actually a lot of this is milliamps, but you know, why be absolutely, you know, specific about it? But not really a whole lot of current and a lot of this either, but like I said, I've never had this stuff in the past to ever interfere with anything, so I am going to go and just work all this stuff in here thoroughly until I'm satisfied. And then I'll put all of this back in its housing, and you know, who's going to see all of this anyway once it's all back together. But for those concerned, you know, about a safety measure, this is my safety measure on this type of stuff. And it'll settle down and kind of self-level. And it really should not interfere with the operation of any of this immediately or later on. And if you do end up having to remove it at a later date, hopefully you don't, it will actually remove a lot cleaner and easier actually than that clear sealant coating that this originally had on it. So I'm going to give this a couple of hours or whatever, at least a couple of hours to set and harden. And this stuff will set up a lot like just lacquer. And it should be totally alright. And then this thing will be ready to put back in the cover and everything and reinstall, and we'll take a final ride. I was going to skip showing this step, but in the interest of completeness for those entirely new to all of this, this goes back together differently from the way I took it apart. If you'll notice here in the back, we've got locating studs right here and up in the top middle right here and right here. And when I pick up the board, you can see the corresponding holes for those right here. So putting it back together, you just want to start by setting this down into the back. And I've already done the final cleaning on the overlay and everything, which is, again, it's thoroughly stuck. And of course the next step after you've thoroughly cleaned it and all, because it's going to be your last chance to get inside of it, is to snap this back on after you have put all of this into the back already and lined up all the locating studs. See, right there and there and right here. So we're into a long video already, right? So let me go ahead and show it all. Okay, so there we go. One more time working through the camera. What can it hurt? What can it do other than just ruin everything, knowing my luck? But, oh, there we go. And then, right here. Oh, come on, there you go, right there. Right here, all right, snap tight here, here, and here, all the way across the top. And then down here on the bottom, there we go, right there, here, and come on, there you go, right there. Got to give it a little help sometimes. And right there, all right. And my OCD complex, I've got to check everything a umpteen dozen times, but there we are, fully assembled. Also out here at the car, I should point out that from the instrument cluster bezel, I'd already removed these. They were coming through right here, that little assembly. So I took them out of this. And I haven't checked them yet, but I've already gone ahead and plugged them back in here because this circuit right here contains the dimmer control for all of the panel lights in this car. and it is therefore part of the circuit of the speedometer backlight assembly. Just a quick note, whenever you're doing this type of thing, remember that not all the associated circuitry is contained right in the main assembly itself. Some of it is extended out, and I don't know whether it would still illuminate or not without this, but I didn't even bother to try it. For the previous demonstration, I already had this removed and plugged back in. And also, the entertainment system and climate control assembly. I've already, for the previous demonstration, I had all of this just set back in, and I'd already reconnected all of this, but it's not fully seated and mounted. It's just set back in, just to keep all the circuitry in the car complete. And here we have the speedometer, temp, and fuel gauge assembly fully reinstalled. I've already got it plugged in, mounted with 3 number 2 Phillips head fast thread screws here. Nothing much to see. Just be aware that when you're reinstalling this, that on the top on each side there is a locating stud down below where the screw goes that you have to line up. And you can see that since the door has just been recently opened, we still have that dim glow right there at the speedometer. That's a good sign. So, got the key. Gonna put in the ignition. All right, it just brightened up. That's another great sign. There's our annoying car alarm. But anyway, all right, there it went. It went out then. Switching on. And we've got a good looking gauge check here. And yeah, I've already put some gas in this thing. And already actually driven it around some, so it's already down a notch. But I'll do this again so you can see that was a full display, a full gauge check that just went excellently. There we go. All right, that's great. So great that, based entirely on the strength of that, I'm going to go ahead and install the upper cover for the driver's instrument panel. I am ready to see this car start coming back together. Refer back to video 1, anybody who's not seen or otherwise forgotten what a job it was getting to the point where this could actually be accessed and pulled out. I don't even want to get into all of that here in this video. Anyway, gonna start by pushing and snapping in kind of downward at an angle here at the front. There we go. Come on. Set everything. There we go. All right, finally going home. There we are. All right. And we've got number 2 Phillips. Goes in right here. And then 2 more. And the third one, just go back to part 1, y'all. When I say getting that last Phillips head screw for this out from right here was an adventure, I am being very, very, very kind. It was really some kind of an adventure. the kind I do not want to repeat anytime soon. So hopefully, fingers crossed, I won't have to. Because, yeah, Honda made this thing where all of this has to come out just to get one screw out from right here. Plus the little bit of a lip right there that's covered by this. So, everything it took just to access the speedometer, temp, and fuel gauge assembly in this car just kind of felt backwards to me, that it would all have to come apart from the bottom up. But hey, that's what happened. All right. Walk with me. My gosh, at the walking I have done in this video, one side to another, back and forth, back and forth. But there we are. Finally. Okay, let's see if my supreme confidence can pay off here. Gauge check. All right. Start up. Looking good. Looking damn good. And that looks even better. Okay, y'all. Sorry about the long video. I kind of got into a tight on this one, which I had to wiggle out of, but I think the results speak for themselves. I debated how much to edit out of this video to try to shorten it for people, but in the end I decided it should include just about everything, you know, that you might get into doing this kind of work. And everything this job put me through, I think I covered a pretty good bit of it. But anyhow, we've got working instrumentation, and this will finish up everything for the speedometer and temp and fuel gauge assembly for this 2008 Honda Civic. And next week we'll get into some more of it as we start piecing it all back together. While I'm into it this far, I want to at least do a check and overview of everything else that had to be pulled out to get to this. So tune in next week and we'll explore some more. Until then, y'all be good to each other. Y'all be kind to each other now. I know y'all are all the time, but anyway. It feels nice closing a video just saying that, but y'all take care out there. And don't be afraid to work on these things. You know, like I said earlier, if it's not working, it's already ruined itself. So as long as you're doing conscientious work and all, and being careful, there's no harm in trying. So give it a go if you need to, and if you're daring enough. Let me get around here again and we'll do another Doc Emmett Brown. Get out of these curves. When this baby hits 88 miles per hour, you're gonna see some serious Okay, it wasn't. We're good. Take care, everybody. Brooks Hobby Shop. We're out. Almost forgot. Turn signal check.